Okay, so this is the high tier question 5. Okay, now this question deals with the Newton's laws section of your syllabus, and specifically with the specified practical work investigation of the terminal speed of a falling object. So the specified practicals are the ones which they will ask questions about in the exam, so you do need to be familiar with all of them. Okay, so this basically is the cake case experiment that we did. So if we go to the question itself, it tells us an experiment was carried out by students to investigate the mean speed of a stack of 6 cake cases falling from different heights. Light gates were used to time the falling cake cases. The vertical distance between the 2 light gates was adjusted so that different drop heights could be investigated. The apparatus is shown below. So we've got the 6 cake cases. A light gate is simply a sensor that notices something passing by, and they're both connected to the same computer, and therefore the clock in the computer measures the time it senses the cake cases passing this light gate and the time it senses the cake cases passing this light gate, and it works out how long that time was rather. And then the experimenters can adjust the drop height by moving the light gates further and further apart. Okay, which is a slightly different way of doing the experiment than we did, but the idea is still the same. So we've got here a graph of the mean speed against drop height for the 6 cake cases is shown below. Okay, so we can see as the drop height increases, the speed at which the mean speed increases initially, but then eases off to a constant. So it doesn't matter how high you drop them, after around 1.5 meters, we always get to the same speed. And of course, that means that this is the terminal velocity for 6 cake cases. Okay, so in other words, at about 1.5 meters, 6 cake cases will reach the maximum speed that they can. They can't get any faster. So the question says, describe how the mean speed varies with drop height between 0 meters and 1.5 meters. Okay, so I had got an answer down there, but I didn't like it very much. Okay, so what we could say that the speed does increase, but the rate that it increases drops off. Okay, or reduces or decreases. So the rate, the speed increases. Okay, so by saying that the speed increases, we're acknowledging that it is increasing, but it's the rate that decreases. Okay, so the rate that the speed increases decreases, which might seem to not make sense, but we're commenting on the rate at which it increases. So it gets less and less and less until the rate of increase is 0. Okay, at the point where the line is horizontal, the rate of the increase of speed becomes 0 because it's not increasing anymore. So use the graph to state the value of the terminal speed for the cake case. Okay, so what is the terminal speed of these cake cases? If we take our ruler and place it on our graph horizontal with the maximum speed, and we just draw a line back to the axis, we can see that it's pointing at halfway between 1.0 and 1.2, therefore that's 1.1. Okay, so we've got 1.1 meters per second is the terminal velocity of 6 cake cases. Name the 2 forces acting on the falling cake case. Well, of course, we've got the force of gravity, which is affecting the weight of the cake cases, and that's pulling the cake case down. But then we've got air resistance. So as they fall through the air, they meet the resistance of the surrounding air, and that slows them down. And then it says, compare the size of these 2 forces when the cake case fall at terminal speed. So terminal speed, just in case we've forgotten, is the speed where the cake cases will get no faster. It doesn't matter how high we drop them from, they're not going to get any faster. And that's because the force of gravity and the force due to gravity and the force of air resistance are the same. They are balanced. Okay, so the cake case is falling at a constant velocity. So because it's neither increasing in speed or decreasing in speed or accelerating or decelerating, then we describe it as experiencing balanced forces, and those 2 forces are therefore the same. Okay, so that was question number 5.